Hello fellow engineering. So this is the wrap up of my previous episode, and I will try to go in detail what I actually did here. It's related to our new BOXCAR and some new features where you can actually trigger not only the time domain but frequency versus time and magnitude versus time, which could be very useful. So let's dig into it. So first of all here, if you look at this display, I put it in persistence mode. So if you take this, like auto, you will see I'm actually trigger on something here. And this is a trace called frequency versus time. So I will just stop this for a while. I'll go back to channel. And channel 1, I turn it off. Oh, I'm in the middle of the channel. So this is how it would look like in a time domain, completely undersampled. So then I went in here for the acquisition here, and I put this one up a little bit so we can have, this is a 2.4 gigahertz signal, so this one, and if I do a signal preview and stop, so this is how the signal would look like. If we try to extend this display a little like this, I can do a zoom here so you can see what it is, if I can do it, and I can zoom a little bit. Oh, it's the wrong way. Zoom a little bit. So this is kind of a sinusoidal frequency hopping. It's a demo chord. So this is what I've done. So instead of looking at this from, if I go here and actually measure now, it will make sense. If I go and measure the frequency and add those, and I do time trend, you will see that the problem here is that it's kind of noisy, this signal. So we're looking at the CV signal here, and we go from this to this. So what you need to do here is a little bit more filtering. I think you can do that filter. You can have a low pass first order filter, and this is where you're getting to see the same thing. The thing is that it's not done by the same thing. It's done a little bit different. So going back from forward, I will do this setup again. I will show you the triggering, but do a default setup. So default setup. This is a BNC connector. Let's put it into 50 ohms. Oh. Right click, auto set. So this is the starting point. So when this is up and running, you get this. It's not what I did. So what I did here, the second thing, I went in here. I put what we call spectrum view. Oh, I need to kind of move my chair a bit. I turn on frequency, and I can turn on normal and put this on. That gives me, a spectrum. And if you've been on the tech before, we have always integrated like spectrum view and time overview on some or more models. So this one, the center frequency is 2.4 gig. Enter. And I reduce the span to like, I don't remember, like this. So this is what's going on. And as we have a very, very shallow memory, as like 200 picosecond, you will not really see this one. And I think I actually had this one as at 2. Was it 2? I think it was 2 or 5. I don't remember, 2 or 5. So you can see it's kind of unstable. So what I did now is a little bit more timing. And now comes the real trick. Instead of triggering on this signal, I will go up and I will trigger, and I have a selection. So the first 3 things here I can select this one. So instead of analog, I can go to frequency versus time. And it gives me kind of a threshold. And what I did in the video, as I was doing this one, I take either one, and then we had a little bit more time. And now you start seeing this back. So the display here, which is channel 1, the analog domain, I don't care about that anymore. So this is what I did. I removed that one by saying don't display it. The second thing I want, I didn't reveal this one, so I hide it. So I had this one. So what can you do with this? What's this useful? So I'm triggering on a frequency hopper that is lying around 2.4 gig. I have a span of 100 megahertz. I have a trigger now up and down. So if I go for the trigger here and saying that the trigger should be the rising edge, I could possibly move this one up until I had almost no triggering. And again, as we work with triggering, always make sure you put it in normal mode. So now I have two different waves. If I push this a little bit, I'm starting to get kind of a stable signal. Kind of. It's not perfect. So the thing is, what can I do now with this? And I see that there's some disturbance. So let's go a little bit shallower to 50 megahertz. Just look at this. And if we say that this is probably okay, I will go a little bit longer. So one of the things you can do with this one is, for example, if you have a radio that's frequency hopping. So you can see that I have a stable trigger. You can see that there's some difference over here. It goes up and down. So one of the cool things you can do is, if you go through a scope and you have an option for mask testing, you can then draw a mask. You double click here and say waveform tolerances instead, and you put 100 milli, hopefully, enter, and 100 milli. I can just do like this, 100 milli, enter, and then update mask now. So in this case, I can actually do the mask testing on. The thing is that it will only reveal when the mask is broken. So this is basically what I did. I cheated you a little bit because I didn't, in terms of the triggering, I didn't have it stable. I put it in the middle a little like this and had like this. I think it was something like this. I had a little bit shorter time like this. And then I made the persistence to variable, and I think I put it to, was it like 10 seconds or something. So this was the kind of the trick I did. Maybe it was even shorter, I don't even remember. Something like this. So it's just in a very different way of collecting a signal. I will do a more thorough, on this subject, how you can trigger on a single Bluetooth event with an antenna connected to the scope, where you use this methodology or technology. And next week I'm not sure if it's visible on my YouTube page now, but next week there will be a live event. Me and a colleague with me will talk about scopes, what happened with scopes, the evolutions of scopes and probes, and I hope you have time to look at it. But so this is what I did. I'm trigger on a frequency. I'm trigger on the frequency versus time trace from our digital down converter, more or less. Simple. See you soon.